Welcome, Math 3 students, to our final unit, Unit 7. The topic of Unit 7 is statistics. So this will be kind of a brief overview of some of the things you will come across in a college statistics course. If you like this type of math, then consider taking AP statistics next year or the year after. Okay, so our first lesson. Lesson 7.1. The topic here is how are we getting our data? Statistics is analyzing data. So before we can analyze data, oftentimes we have to go collect it. So these are the different ways that we can be getting our data. So there are surveys, experiments, observational studies. And that's the first thing we're going to go over here. So what's a sample survey? What's an observational study? And even more generally, what is a survey? And what's an experiment? So a lot of reading here. Feel free to pause the video, read it, and then check if you got the answers right. Or just follow along. So let's see, broadly speaking, a survey is a way of learning about a group of people by having some of the people, okay, but not all of the people. If you had all the people in the group, it would be called a census. Okay, so I'll jot that down. All people, that would be a census. Which, by the way, our government is attempting to do the 2020 census right now. Every 10 years, our government tries to get data on everyone in the country. And when we do that, it's called a census, as opposed to a survey. A survey is a subgroup of everyone. Okay, so it doesn't include everyone. All right, so anyway, it might involve completing a form, completing a questionnaire, or participating in an interview. All right, next, an observational study. Is a type of study where a researcher uses observed information to learn about a group of individuals. The individuals being observed are specifically not interfered with, aside from the measuring of their responses. For example, if we wanted to learn if a person's hair color is related to his or her favorite soda, we would record values of the variables hair color and favorite soda from observation or from reported observations. Okay, so the key thing with an observational study is we're basically just going out and getting the information without really interacting with the subjects in any way. Okay, next we have a sample survey. Is a study that is carried out using a smaller group of people who are intended to represent a larger population. Okay, so again, this is a survey. It's not a census. For example, if we wanted to know more about the opinions of the 1 million adults who live in a particular city, we could randomly select 900 individuals from those 1 million and conduct a study. Well-designed studies of this type can provide data that can be used in a variety of ways. For example, it might be used to assess the views of the general public, to examine trends in customer behavior, or to estimate the values of population characteristics when a census, there's that word, of an entire population is not practical. And very typically, the census is not practical. It takes way too much time and costs way too much money. Okay, moving on to our last choice. This would be an experiment. Okay. It's different from all other studies because now the researcher deliberately imposes different treatments on different groups and then compares the groups to determine if there is any difference in a specific variable of interest called a response or response variable. A well-designed study of this type allows researchers to decide if the different treatments result in different responses. Okay, so that's very much used by scientists when they are trying to develop treatments for diseases. So they'll compare different treatment groups and try to determine if their treatments are effective and or find the most effective of the available treatments. Okay, part 2. Here, you're going to go ahead and read different scenarios and try to pick. Is this an experiment? Is it a sample survey? Is it an observational study? So go ahead and pause the video, read these, and try to determine which one we have. All right, so let's go over it. Letter A, a pharmaceutical company is interested in comparing 3 brands of pain relievers. The company wants to know if one brand is much better than the other brands in terms of mobility improvement. 3 different groups of 30 people participate in the study. Each group gets one of the 3 brands of pain relievers. The improvement in mobility of these 90 people is recorded after 5 weeks of taking the medicine. Okay, so the main thing to notice here is that we are imposing a treatment on the subjects. We are giving them a pain reliever. So this qualifies as an experiment. Okay, so letter A, that's an experiment. Okay, moving on. Letter B. Medical records of a group of long-time residents of a town are compared to the medical records of a group of long-time residents of another town. Researchers are curious to see if one town appears to be healthier in general. Okay, now notice on this, there is no treatment being imposed on the subjects. We're just looking at data that we are basically just observing, right? We're not interacting at all with these subjects. So this is an observational study. Okay, so that's letter B. All right, taking a look at letter C. A group of 600 registered voters in a given county are asked how they intend to vote in an upcoming election. A summary of their responses is posted on a news website, and it is implied that this group is representative of all registered voters in that county. The responses are used to predict the outcome of the election. Okay, notice there's no treatment being imposed here, but we're not simply sitting back and observing. We are out there actively getting the data. So we're getting the data by using a sample survey. Okay, on to question D. In a study to see if administering a medication orally or by injection makes a difference in how quickly people with back pain feel relief, a group of 400 adults suffering from back pain is divided into 2 groups. One group of 200 people is given the medication in pill form, while the other group of 200 people is given the medication in the form of a shot. Results for each group are compared to see if there is a difference in pain relief between the 2 methods. Okay, so this one you can see we are administering a treatment. Since we are administering a treatment, this is an experiment. Okay. All right, so let's take a look at the next page. Okay, so aside from the different studies that we can conduct, the way that we select the participants in our studies is very important. It's very important because we don't want to have misleading data. We don't want to have misleading results, okay? And one of the keys to trying to avoid these misleading results is to use random selection. So randomization is key. There's really kind of two general types of randomization. One is random selection. So if I'm doing a sample survey or an observational study, I want to randomly select the people that I will be giving the survey to, or the people that I will be looking at data from. The other thing would be random assignment. This is when I have an experiment. So I have a certain number of patients that suffer from whatever condition that I'm trying to treat, and now I need to randomly assign them to the different treatment groups so that I can, again, get fair representative results. Okay, so go ahead and take a second, read this top section, and then we'll go over it. So pause the video. Okay, so you're back. We're going to go back and revisit the problems from the previous page, but we're going to add on a little new information. And there's a really, really important word here that I want to make sure everybody sees. That word bias. Okay, that is why we need random assignment. We are trying to avoid bias. Okay, bias is a systematic favoritism of a certain outcome or outcomes. So in other words, it's non-representative data. It's bad data when I have bias present. And there's no way to fix bad data. If you have bad data, you have to throw it out and start all over. So it's very important that we try to avoid bias in our data. And again, the way to do that is by using random selection or random assignment. Okay, so let's go back. These are the same setups that we already read through, but we're adding. So example A, this is comparing the pain relievers. Okay, this time we've added in some information. The first group of 30 patients were patients of Dr. Winkler. The second 30 are from Dr. Singh, and the last 30 are from Dr. Manganon. Okay, do we think that this could create bias in our results? And the answer there is yes. We have now created what we call a confounding variable. So I'm going to move this. It's really hard to reach and write this much. The different doctors are now a confounding variable. See, we don't know if the observed differences are due to the different pain medications or the fact that we have different doctors and maybe one of the doctors is just a better doctor than the others. Okay, so we can't have a fair, unbiased comparison. Okay, so we call that a confounding variable. All right, take a look at letter B. This is the observational study. We were trying to compare the two different towns and see if one of the towns is healthier than the other. Okay, the new information. In order to save time and money, all of the records were selected from the largest of 4 hospitals in town X and from the largest of 3 hospitals in town Y. Okay, is this going to potentially bias our data? Again, the answer is yes. We have a potential source of bias. You see, the size of the hospitals is now a confounding variable. So when I observe differences, I don't know if it's because I'm ignoring smaller hospitals. See, I've created a non-representative sample that I'm trying to draw conclusions from. And that's not a fair way to draw conclusions. I need a representative sample. So I need both small and large hospitals data. Okay, moving on to example C. This is the one where we did a sample survey about voting. The new information is the 600 voters submitted their opinions via a web page and were able to choose to participate after seeing an advertisement on television. Okay, this is a real common source of bias in sample surveys. It's so common it has its own name. This is called voluntary response. Okay. And voluntary response almost always leads to bias because it's a non-representative sample. When I ask people to volunteer their information, I'm only going to be getting a certain subset of the population. I'm going to be missing out on the people that aren't very opinionated on this particular matter. So I'm only going to be getting the extreme viewpoints, and I'm going to be missing out on all of the middle ground. So we call that voluntary response, and it's a form of bias in and of itself. So there's a term, this is called voluntary response bias. Okay. So we want to avoid voluntary response bias. Okay, on to our last example. Okay, this one again was an experiment where we were comparing treatments, but the new information. People were allowed to select how they would take the medication. Once 200 people had filled up one of the groups, all remaining people were immediately placed in the other group. Okay, so we're trying to compare the injection versus taking pills. So do you think that this method of selecting the subjects and dividing them into the two different groups could create bias? Again, the answer is yes. This can create bias. We want to use random assignment here. By not using random assignment, the subjects might already have an opinion on, I prefer taking a pill, or I prefer taking an injection. And since they already have that opinion going in, that can bias their results. Okay, so by not using random assignment, we allow subjects previous opinions to potentially bias our results. Okay. Again, the key thing here is we're using randomization, random assignment, to try to get a representative sample, a representative experimental group. Everything we do, we want it to be representative and as evenly distributed and fair as possible. So that's why random assignment is so very important whenever we are collecting data or setting up experiments. Okay, I hope this helps out.